Hey guys. So I'm recording on my Surface, or not my Surface. I wish I had a Surface. The computers that I have here, and it's just not what's up. So I'm struggling a little bit. But anyways, I'm not here. Baby wasn't feeling good. I want to make sure that I get you guys everything you need to get through day two, for the trig stuff. So for right triangle trig, hey KK. Today we're focused on ratios. So ratios are the comparison of the two side lengths. So in the first part, you're gonna use a calculator to find the ratio to a given angle. So on the calculator, if you have one like this, we're looking at these buttons here: sine, cosine, and tangent. So for the first one, if you type in, oh, that's not cosine. I can't look that way. Let me do this again. So sine of 32 degrees, um, and then you hit enter. You get 0.5299. So that means if you took um, the the ratio, that would be what you would get from dividing it out. So in this case, I like to go to 3 decimal places, but here we would have to round this to 0.53. There we go. Point. It's not letting me do this. Hang on. Use my mouse. 0.5. Yeah, these computers are not good at this type of stuff. And the cosine of 33 degrees, tangent of 75 degrees work the same way. So cosine of 33 degrees, make sure your calculator's in degree mode, and you'll get 0.38. I'd round that up to 0.89. Again, the reason why you don't want to round early is you never know how precise you need to be, and it might not seem like a lot in a like an application that actually matters. Rounding off that a little bit might mess you up. So the other ones, the cotangent, the secant, the cosecant. KK, let's see, baby. Hey, mama, say hi. Say hi. Um, you need to do the same function, but we got to remember that they're inverses. So if we're looking at the secant of 13.2 degrees, secant, we're going to do 1 divided by, secant is the inverse of cosine, so of cosine. So it's going to be 1 divided by cosine of 13.2, and that's going to get you your ratio of 1.27. So that is the ratio for secant. So for cotangent, cosecant, make sure you put it as 1 divided by the function that they're inverses of. All right, so that's the basics there. Back to my arrow. Where's this pen? Okay, so for the next part, use a calculator to find the measure of each angle in degrees. So we found the ratio. Now we're going to find the angle. So to find the angle, you have to use the inverse button. So if you're looking at your calculator, you have to hit second first. You hit second and then sine or cosine or tangent. And that's going to give you the inverse of this. How you find angles. So that's what I would write in this part. Well, what buttons functions? Use second sine, second cosine. Use the inverse function, the inverse sine, the inverse cosine, inverse tangent to find the angle measurement. So we'll type in 1.2. That's for tangent. For sine, we got 0.5995. 5995. Oh, I cannot type today. Okay, so look like this. Hit enter. So the angle measure, the theta in this case, would be 36.834. 36.834 is what you would write for that. So A would be 36.844 degrees. Well, yeah, you haven't done math. 844 degrees. Where these are angle measures. Tangent works the same way. Now for secant, let me make sure I get this right. I left my notepad at school because I thought I was going to be there today. So secant is the inverse of cosine. So the way it's going to go is you're going to do 1 divided by second cosine 2.348. That's not it. So let me pause this real quick. Okay, I remember. So what we got to do, so let's use secant of k equals 2.48. So that's the ratio. What we're going to do is we're going to do second, secant is inverse of cosine, so second cosine, and then you're not going to put in 2.348, you're put in 1 over 0.348, because you're trying to get the inverse. Yeah. And you get 64.73, I'd round that to. 64.793, and obviously sometimes they only ask for one, a tenth, hundredth, but I'm just going to try to keep you guys being precise as possible. That's at math practice 6. So that is how you find the angle measure when you're getting a ratio. So that's 2 different things you can do with your calculator. All right, so we're back at it. We're on this next part. So for letter A, suppose theta is an acute angle of a right triangle. So draw a picture for all these. You can put the theta here or there, whichever one you prefer. You're given one ratio. You need to find the other remaining trig functions. We were just talking up a storm. So sine is so, right? Sohcahtoa. Opposite over adjacent. So that would mean opposite is square root of 5, and the hypotenuse is 4. Now, I'm gonna get stuck because I don't know the adjacent side. So you need a Pythagorean theorem this out. You're given the hypotenuse in one of the legs. So it's gonna be 4 squared, so 16 equals square root of 5 squared is 5, plus, let's just call it a squared. So then you solve, you get 11 equals a squared. We take square root of that, and you're gonna get a equals the square root of 11. Square root of 11. Man, this drawing with this mouse pad is literally the least you're doing. Come on, come help me out. Mira, right there. You're right there. Say hi. Say hi. Yeah. You want to go back down? It's okay. Go. All right. So we have our side lengths. We did Pythagorean theorem, and now we just need to figure out the rest of these. So this is what we did day one. You just go with, so cosine of theta would be adjacent over hypotenuse, so square root of 11 over 4. Now, when you do something like tangent, and you get opposite over adjacent for the toa, and you get square root of 5 over the square root of 11, you got to remember to rationalize that. I'm going to change my color because I'm running into this big triangle. With the red. We have to get we have to rationalize it by multiplying by the square root of 11, because you don't earn a rational number in the denominator. So we multiply top and bottom, numerator, denominator by square root of 11, and it's painful, guys. It's so painful. But we're doing this to give us a number that's not so messy, like square root of 55 divided by 11, and there's nothing we can pull out of there, so it's just going to be our ratio. So for tangent of theta for this triangle, you're given that. Now, what you do here is find out the values in degrees. So let's do that by getting our calculator back out. All right, so once you get your ratios out, then you can go back to your calculator and plug them in. Now, if you're, depending on what kind of calculator you got, like I have this one, and it's not as powerful as like the TIs, the big ones, you gotta kind of play with it to make this work. So the first one, the sine of theta equals square root of 5 over 4. I gotta plug that in my calculator. Now, if I just type in the square root of 5 divided by 4, it's gonna make it all one term, and that's not what I want. That's not what I want. So I have to go square root of 5 by hitting second square root, 5, and then I'm gonna hit enter. This one inverse is killing me, and then I have to go divided by 4. Now that gives me the ratio. Now to turn this into the angle, I need to go second sine. You gotta use the inverse function. Second sine. Now you can't just type that in. At least I'm not doing it right. But I'm gonna go second answer. And the answer is above the negative sign right there. Second answer, and that's gonna take that last answer you had, which is square root of 5 over 4, and plug it in. Hit enter, and then you get your degree measure. So in this case, I'd have 33.988. We went off to 3 decimal places. 33.988 would be your degree. So you want to get, for all of these, find the ratio in fraction form, and then plug them in to your sine function or your inverse sine function. Remember, when you're doing this, to plug it in 1 over your ratio. So good luck with that. Same thing for letter B. And then I'll scroll down, so give me a second. All right, so we just went through the notes. Now let's go through this. So this is using your extended ratios on your 30, 60, 90s. These are your special right triangles. For the special right triangles, you got to remember what each of the side lengths are. So let's see if I can remember this. So 30-degree is an x. 60-degree is x times the square root of 3. And your hypotenuse is 2x. So what you got to do is you got to solve for x. And once you know x, you can do the rest. So x is obviously going to be equal to 13. So you know that this one is 13 times root of 3. So I'm just going to do that. Now, if you wanted to do something further with this, trig ratios, you'd be able to do that. That's how all 3690s work. It doesn't really change. I gotta get rid of this pen. So for the 45, 45, 90s, same deal. You got to remember the ratios. So if we remember, we have for the 45-degree sides, x, they're equivalent. And then for the hypotenuse, you have x times the square root of 2. So if one of our side lengths, if our x side length is 6, then we know that our hypotenuse is 6 times square root of 2. It's that simple. It gets a little more tricky if they're giving you the hypotenuse, then you have to solve. But you guys can work on that. Let me erase this pen. Let's keep going. Find the trigonometric ratios for each triangle. Looking at number 1, let's do number 2 because I just don't feel like doing big numbers right now. This is going to be a Pythagorean triple, which if you don't know what that is, there's a ton of them. Google it. But the side lengths are 3 and 4. So if you do them with what do you get? What do you put in? What is that? Give me that, bro. Plain babies eat everything. Well, this baby does. Pythagorean theorem: side length squared plus side length squared equals hypotenuse squared. So we get 16 plus 9 is 25. You just square root that 5. So that's how you know, even if you didn't know that that was a Pythagorean triple off top. And then we do Sohcahtoa. You guys know that you look at your reference angle, which is right here, and then opposite would be 3, adjacent would be 4, hypotenuse would be 5. So this would be 3 over 5 for the sine of that angle. Tangent would be opposite over adjacent, which is 3 over 4. Oh, my baby's crying. Did you hit your head with the calculator? Yeah, that's what you did. Math hurts. Come here. Come here. Where's your wubba? Hi. All right, let's erase this real quick. No, you can't do it though. So looking at these guys, same deal. Do the Pythagorean theorem, find your missing side length, and then plug them in. Remember that the inverse function is flipped. So you got to know that cosecant is the inverse of sine, and cotangent is the inverse of tangent. Secant is the inverse of cosine. Let's pause real quick. Okay, so for these ones, I really like these problems. You guys gotta be, you gotta think a little bit. So if you're given cosine equals of theta equals 9 over 41, well, that would be adjacent. Oh, you are getting so fussy with me. Oh, that's not going to be 41. That's going to be 41. Now, that's what that tells you. Now, you have to find this missing side length, with which I will change colors by doing the Pythagorean theorem. And when you do the Pythagorean theorem, you can find all the other ones. So, I know we didn't talk about that, but you can do it. You can do it. Scroll down. Let's erase this pen. Finding the angle measure of the angle indicated. So number 7. Well, look at the theta, and what side lengths do you have? Well, we have the adjacent and the hypotenuse, so that's going to tell me that I'm going to use cosine. So it's going to be cosine of theta equals 12 over 13. Adjacent over hypotenuse, 12 over 13. So that gives you the ratio, but we don't want the ratio. Girl, you're messing me up. We don't want the ratio. We want the angle. So what we got to do is we got to solve for theta. And to solve for theta, we need to get theta by itself. So how do you get rid of a cosine? Your first reaction, you're probably like, well, let's just divide by cosine. That's not going to work. What you got to do is do the inverse of cosine. Inverse. So we're going to take the inverse cosine of both sides. And when you do that, the cosine on the left-hand side, you're saying hi. The cosine goes, why are you saying hi? Good job. See, you can do it. She never does it when we ask her to. And then we're going to plug 12 over 13. We're going to do the cosine. Why don't you crump it? Cosine inverse of 12 over 13. So what this lets you do is what we were doing earlier. And you're going to take your calculator and you're going to go second cosine, inverse cosine, 12 divided by 13, and that's going to tell you your angle measure in degrees. Make sure your calculator's in degree mode. Here. So that's how you do all those. Now this one says rounded in the nearest tenth, so you don't need to round out as far as I usually do. Let me erase that. And we're done. And find the measure of each side indicated round to the nearest tenth. Let's pause for a second so I can get one of these going for you. Okay, so here's why I always say guys, like algebra and your solving equation stuff is so important. So you see I set up an equation here, and I'm going to explain it. So we got angle of 37. That's our reference angle. That's what we're given. We need to find the measure of each side. So we need to find what x is. Normally we do Pythagorean Theorem, but you have to know two side lengths for that to happen, or have a special right triangle where you know the identity, and we don't have that right now. So what you do have though is you have two side lengths. You just don't know one, so that's x. So we're going to figure out what trig ratio we have. So if we look at 37 degrees, we have the adjacent and the hypotenuse. So that's cosine. We have cosine of 37 is equal to adjacent 11 over hypotenuse. So all you have to do is solve for x. So you multiply by x on both sides and divide by cosine of 37 on both sides. And I'm going to just shortcut this a little bit because this writing is hard. But basically all you're going to do is put in your calculator 11 divided by cosine of 37. If you're not confident that your calculator is going to listen to you and do the right thing, what I would do is figure out what cosine of 37 is first. Are you going crazy? Hang on. Cosine of 37 is first, so it's going to be 0.79. So then you can ask yourself, okay, what would 11 divided by 0.79 be if my calculator doesn't listen? But I'm going to plug it in normally and see what I get. So 13.77, when you divide by a number less than 1, that should work. So just to be sure, let's go 11 divided by 0.79 to get a guesstimate. And I get 13.9. So that's what you do. You plug that in, and that's going to give you your missing side length. If you want to keep going, you could then Pythagorean theorem to get the other side length. You can do you can figure out the other angle measure, and you're good to go. Let's see if there's anything else on here that we want to do today. No. There's day 2 stuff. You guys can practice that. So again, sorry I missed you guys today. I'll be back tomorrow. It's Mr. Answer 404. Subscribe. Let me know what else you guys need to do for you. Thanks. Okay, say bye. She ain't saying bye. She's trying to do some math.